when we draw the syntax diagram, all the non-terminal, we will put it in also, right? But when you convert to the master diagram, all the terminal, non-terminal here, we won't show it. So another way to say is, if let's say we want to draw a master diagram now, right? In the final answer, what we should have is only this one, the digit only. So we need to convert everything in the master diagram, like this one, unsigned integer, decimal fraction, all this, you need to replace it with digit. Okay? Because only digit are the terminal symbol in this case. All the rest are non-terminal. So we cannot put it in our master diagram. Okay? So now try, if let's say we combine this one, the decimal number is the starting point, and after that, in the decimal number here, the unsigned integer, we need to replace it with digit first. Correct? So this diagram, it will becomes decimal number, first one, this first here is unsigned integer. So the unsigned integer we need to replace with this whole thing here, which is digit unsigned integer. So we will replace with this. You want me to write digit first? If I write digit first, then we don't draw the digit here first. I write the simple one first. So I will replace it with a digit. And then this is the first one. Just now the decimal number we need to substitute with unsigned integer for the first line, right? This one, unsigned integer here. So we substitute the unsigned integer with this one, which is a digit unsigned integer, or digit only. Okay, so we have this. Either you substitute with digit only or digit unsigned integer. Second one, you need to substitute with a decimal point with a decimal fraction. So the decimal fraction also need to substitute with digit unsigned integer. So same also, we will substitute it with a digit. And unsigned integer. Okay. And the third one is unsigned integer and decimal fraction. So the unsigned integer, again, we will substitute it with digit unsigned integer. Same thing, But the decimal fraction, you have a dot decimal point, and then there's unsigned integer. And this one. These are the three alternative lines that you have in the previous syntax diagram. When you combine it, you don't have this unsigned integer already changed to digit. Unsigned integer, decimal fraction already changed to decimal point, unsigned integer, and the unsigned integer already replaced with digit, unsigned integer. So that's why you have here decimal point, and then this one is actually a decimal fraction, right? So the decimal fraction already substitute with the digit unsigned integer, and last one is this one, unsigned integer again with decimal fraction. So unsigned integer itself substitute with this digit unsigned integer, decimal fraction substitute with decimal point with unsigned integer again. So at the back you still have another digit unsigned integer, which is this. So is this the master diagram that we want to draw? Can we put the answer like this? Do you still have a non-terminal here? Yes or no? Any non-terminal in this diagram?
Yeah.
Yes? You have a square, rectangle, square box, right? So as long as you have a square box, meaning that it is not a master diagram. So replace the D here with this one. This whole thing, you draw yourself. So this one, the digit, you need to replace with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every digit here, you need to replace with this 9 digit. Then only that is the complete master diagram. Yeah, because the master diagram, we don't have non-terminal, all must be in a circle, which is terminal only. So the digit we need to convert to 0 to 9. So you just replace the digit with 0 to 9, so your master diagram will be very big. Okay, any question for this? So you replace already with all the digits. Now we have the last part, the regular grammar and regular expression. So this one is the, you remember previously you have learned the type of the grammar, type 0, type 1, type 2, type 3, type 1. So for the regular grammar here, we will actually write the type 3 grammar, okay, where we need to represent the grammar in terms of asterisk. Asterisk means loop. If let's say we have a loop, then we will write it as B asterisk. So you will understand that this is a loop for B. And then for the alternative, let's say you have A or B, you will put it like this. Either you replace it with A or with B. And if it is in a term together, so you put a bracket. Meaning that in this case, you can either choose A or B only. Because sometimes at the back we still have other term. Like this. So if the alternative is for these two only, then you put a bracket for A or B only. If the alternative is for A or B or C, then you put bracket for A or B or C. Okay, so we will look at this, how to write. So this one we call it as a regular expression. The symbol we use are all these. So I will show you example how to write this. Now the regular grammar is at the left hand side we have one non-terminal symbol, and at the right side we have at most one, and the non-terminal is at the most right. Okay, so for example, if we put the V0 at the left, then at the right we can have A, B, 0. This is a normal substitution. If you write it in the BNF, then you will have B0, A, B, 0. Another example, you can have B0, B, B, B1, or C. So this is the alternative, this is the non-terminal, and this is the substitution, and this is a terminal symbol. Okay? So as like before, when we have the loop, right, we can repeat many number of times. So either you want to write the loop as A asterisk, that means this is the repeated n times, okay, until infinity, or you can write it as A power n, and the n you need to define it is more than or equal to 0. And if you want to write the A or B, you can actually put it in the form of A power n, B power 1 minus n. This one, the n can be 0 or 1. Because when you put A power n, B power 1 minus n, right? The alternative here is if n 0, then your A, you don't have A. If n is 0, right? This one, the A is power 0, so no A. Then the B will be 1 minus 0, so you will have 1B. But if the n is 1, then you will have A, but you don't have B. Okay? This is another way to write A or B. So two ways for a regular expression. How do we want to write A or B? Yeah? So look at this example. A, B as string. What are the possible string we can have if we have A, B as string? Can you give me some of the strings? Some of the string that we can have if they give you a regular expression of A, B as string. What is the shortest one? A only, right? Because the asterisk can be 0. And then followed by AB, and then ABB, ABBB, and so on, right? Okay. So that means the loop can only for B. The B will only repeat but not for A. That is how we write this AB asterisk. Okay. Now AB bracket asterisk. What is the shortest string we can have? Nothing means in a string, if nothing, what do you call? Have you heard of noun string? Have you? Yes, right? Noun string, nothing in the string. Or if you repeat one time, then you will get AB. If you repeat 2 times, you will get AB, AB. 3 times, AB, AB, AB. So this is how the bracket function here. Meaning that when you repeat, right, you will repeat the AB together. How about this? A or B asterisk? What is the possible string we can have? You give me the shortest first. Huh? B is the shortest. B can be 1B or no B, right? So now string or one A. If because this is all, right, meaning that you can have either A or B. So if you have A, you don't have B. If you don't have A, you can have no B also, because the B is a string, right? So if you don't have A, the B can be asterisk 0. So that's why you get a noun string. Then you can have 1B also. You can have 1A also. You can have 2B. You can have 3Bs. Can you have 2A? Can you have 2A?
Yes.
A, no loop, right? So A no loop means you can only have maximum 1A. So the loop is only for B. Yes. And this one, A or B asterisk, means what? Means that you can repeat the A or B, A or B, A or B, A or B, right? Then what is the string in the final answer? Can I have noun string? Okay. That is the final answer. So this one is you repeat A or B, asterisk. This one is you repeat how many times, right? Let's say I repeat 1 time, 2 times, 3 times, 4 times, and so on. So from the one that I repeat here, I can choose every time A or B, correct? So if I don't repeat, the asterisk here is 0, I don't have anything, then I can have now string. If the first one I choose A, then the string I can have A only. If the first one I choose B, then the string I can have B only. If I repeat 2 times, the first one I can choose A, second one I can choose B, or the first one I choose B, second one I choose A, or the first one I choose A, second one I choose A, second one, first one choose B, second one choose B, and so on, right? And then you can repeat 3 times, so you can have A, you can have A, B, you can have B, B, A, and so on. So many possible strings you can get from here. And the last one, AB power n. For the n more than or equal to 1, how do we write this? The string, of course, it can be AB, because if the n start from 1 means that the shortest string will be AB. Okay, so you can have AB, 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 and so on. So another way, if we don't write the n, we write the asterisk, then it can be AB, AB, asterisk. So always differentiate the definition, define the n, and also the asterisk. Because when you put the asterisk, it is understood that it can start from 0. So if your AB now is start from 1, in order to convert it to the asterisk, you must write 1 AB in front to show that you have at least 1 AB. That is the difference if you define using n and using asterisk. Understand now? Okay? So asterisk, you must have to write 1 AB in front. The n, you can start from 1. Okay? Differentiate these two. Later on, when you write the regular grammar, you will always use this. Okay, any question for this? Now, if no question, this is the part that you can write the regular grammar. See this diagram. This is considered as the master diagram. So from the master diagram here, they ask you to write a regular expression to represent the language of the grammar. So how do we want to write if this is the diagram given? Right? Just now I give you try to draw the master diagram already, right? Now you write back the regular expression. What is these 3 lines mean? Yeah? Why we have 3 lines here?
So this is new, but if master diagram, I'm not sure if my answer is correct. In master diagram, if we draw master diagram, because I noticed that you combine them all together. Let's say this nice, because this separate means different channels. So I noticed you combine all of them together. I'm not sure why you combine them.
This is a
你要看选
the W is after the A.
车点的，
So that means the position of your W now is after the A. Okay? Then your W replace with BBW now.
W is replaced with BBW.
Or
Okay.
C now.
Or C.
Right? So if let's say your W is here, you replace it with C, then you go to the right. Then if you replace it with BBW, then you go down to the loop and go back to W
换
again.
DB 或者
And it will keep on looping
做到半
as long as you keep on going down to
可
the
是以
loop
后
here
赚钱
until you
不知道
substitute the W with
销
C. Then C is equal. So as in the master diagram, the position of your non-terminal, you need to know where is it. Then only you can
不知道这
We do not draw it, but we treat it
然
as
后做感官面学的话，
not
跟
draw it
跟
out.
其他
So
人，
that's why if you
当然
combine
过
these
程方
two,
面比较难
you
学，
can
可以
combine,
考
but
虑
you
过程。
ignore this W.
Okay. Then the other question is,
就很像
this
做
is
那
all
种
C, right? So why is it
web tree 啊，
in a separate channel?
要学一点 Java Script 啊。
Like the C. So
而且
that's
做
like
过
because
程以
in
后会
status
做
diagram,
很好。
when it's separate by the
但
lines,
是
they have
你像
different
做
channels.
那
But now we
security
combine
就
all
重
of
现
them
那
in
种
one channel. Why is that?
那种 data
Because
drop 起来，
when you substitute this, right, you can either this or this. As long as you have a junction,
而且
you
会
see
比
there
让
is
你
a junction,
自
right?
己学
The
的，
junction means that you can choose here or here to go.
对啊，
So
你哪怕
that is represent for
Or
个人的选择，
but for status diagram, we cannot do that.
只有两个
Because it's separate channel.
Can actually just now I draw a few alternative answers for the syntax diagram. So you see, this one is also a possible answer for
嗯，好，把
syntax
你
diagram. You can combine it also if you want.
Okay.
就那个朋友
This
他
one
的
I
朋友
just
他都全
introduced,
部
so I
钱，
draw the simple one to show you. When you know better already, right? In your syntax diagram, you already know how to combine it.
第一个
So what is the regular expression for this one? Anyone can give me answer or not? Yes. 3 alternative one. Very easy only, right? How's right? Yeah. So we should write it as the regular expression we can write as LG also, or you just put it as the regular expression in words equal to A or B or C asterisk.
行，嗯，这样子。
Okay. How about this? This one? How to write the regular expression? If you write like that, your answer will be very wrong, right? Can we simplify it a bit? How? It is not wrong. You can, because logical thinking, you can go through A, C, D asterisk or B, C, D asterisk, right? Yes. This is only a simple diagram. You already need to write like this. Later on, when you go to more complicated diagram, then even longer, isn't it? So, how do we want to simplify this so that not as long as this?
Extract SCD.
What are the same here?
CD,
CD, S3 are the same, right? So put the A or B together. So you have A or B
and
bracket
and
and it's and in this case no need to write lah. Okay? C, D, S3. When you write straight C, D combined together means C and D already. In the regular expression, we don't need to write the N. Okay? The C and D means CD already. But if it is or, then you need to write. Because A or B, you need to write like this. Why we put it in a bracket? Because every time when you go through here, you will choose either A or B. Then only you go to C, then only you go to the loop D. Okay? This one, how about this? Yes. A is 3. Yeah, A is 3. B, C, that's 3, like this. Any others? Huh? No, when you go through this line here, when you go down to the loop, but you go through A and the BC, can you go together? Every time you loop, can you loop A and BC together? Cannot, right? You can either go through A and then go back, and then another time come down, you can either choose to BC and then go back again, right? You need to see the arrow, the direction. So when you go to A, you cannot go to BC. When you go to BC, you cannot go to A. Every loop you go, correct not? So if I loop for one time, if I write like this, I can go to A and then BC, right? So to be more specific, we need to put the alternative in between these two, which is A or BC.
The line is not straight from
Not straight from.
when the line approaches A, it curves it a little bit and then curves out to B and C.
So it will go back up. It won't go down from here. Because the arrow is pointing up here. You can go up from this side. It cannot go down from here, right? So when you go to A, it will automatically turn back up already. So it will go down again another time. You go to BC, right? Then it will go up again. When you reach here, you cannot go to A. Cannot go to the right. The arrow is go to the left. Okay? So when you go to BC, you will go up again to the first line, and you repeat, you go down, choose again. Either you go to A or BC one more time. So every time you loop, you can only choose either go to A or go to BC. Either one. So these two, you need to put in a bracket and then loop. Okay? Understand, huh? Okay. So we stop at this part first. Then the last part we will continue next week.